Alright, so this video is going to be for 8.11 Quadratic Applications. The learner will apply quadratic properties to solve real-world problems. Alright, so normally it's a really good idea to read the problem once before you start marking things because, for example, when I read this the first time, I might think 90 feet might be significant over here. But by the time I get to the end of the problem, I see that 90 feet's already been added into this equation. So that, if you can't erase it, that might be a little confusing for you. So I like to read the problem first, then go back and see what the important information is. So one thing that I think is important is height is h and time is t. Well, we have it in seconds, but time is t. Now, since time is independent, like there's nothing you can do to change it, it's always going to be the x value. Well, almost always going to be the x value. So on our equations and on our graph, t is going to be on the x-axis, so it's going to equal x. That's going to be important in a moment here. So it says, find the maximum height of the ball. Well, maximum height is just another way of referring to our vertex. Vertex can be a maximum or a minimum. Now, since it's a maximum, we know that we're going to be opening down. We also know that because the negative is right here. Our a is negative. Okay, so they're asking for the maximum height. So we can go ahead and use the axis of symmetry formula. So the axis of symmetry formula is x equals negative b over 2a. Now, me personally, I like to put parentheses around b and around a, so that when I write my formula, it looks like negative parentheses 2 parentheses. And then I can plug everything in. So for example, I can tell that this is a because it's got the t squared. This is b because it has the t. So 90 goes right here, and negative 16 goes right here. Awesome. So we're going to go ahead and get negative 90 over negative 32, which is positive 2.81. Now, I told you the connection between t and x would be important. Now is where that comes in. So in my equation, I've got right here that x is equal to this formula, because that's the formula. But since x and time are going to be the same thing, this is now equal to t. And that's where I'm going to plug this into my equation. So my equation is h equals, h for height, negative 16. I'm going to leave parentheses here because those are my blanks where my t is going to go, plus 90. I'm going to leave more parentheses. So now I'm going to come back, I'm going to plug in t. Whoops, wrong color. 2.81 and 2.81. And when you get this all solved out, you're going to get 126.56. So I think the biggest problem is going to be which numbers go where. If you get a little confused, just pay attention to the fact that y would usually be right here and x would usually be right here, and that will help a lot. How many seconds will it take for the ball to reach the ground? Well, if I draw a picture here, here's where I kicked it. If I draw a picture here, I kicked it into the air and then it came back down, back to the ground. So I've got this right here where it comes back to the ground. So that, of course, this is just a sketch, guys. Don't take this as the exact picture. But ball gets kicked in the air, comes back down to the ground. Ground is our x-axis. So I'm looking for the x-intercept, or the solution, or the roots of this. So what we're going to do is we're going to set it up and solve for the solution. I'm going to rewrite my equation here. And I'm going to set it equal to 0 because I want it to be at 0. Reaching the ground is run h equals 0. So I've replaced h with 0. Awesome. Now I can divide both of these by some number. And currently that number is, for this problem, negative 2t. They both have a t in them. They're both divisible by 2. And it's nice to get my negative off by a. So I'm going to go ahead and divide by negative. I I need A to be positive. So, well, that went a little too far. Sorry. All right. So now I'm going to end up with, I got to pull out whatever I divided by. I've got negative 2t. On the inside, I'm going to have 8t minus 45. Now, it's equal to 0. This part seems to really trip everybody up, but I'm actually going to pull these two down and set them equal to 0. So I've got negative 2t equals 0. Ignore that weird little mark. I've got 8t minus 45 equals 0. So I'm going to basically take both of these. It's like my factors. They're both my factors. I'm going to set them equal to 0. Now 2t does not equal 0, so there's no solution for that one. But come over here, I can inverse my 45 by adding it. So I inverse the 45 by adding it. I've got 8t equals 45. Divide by 8 to get my t alone. And I'm going to be able to get time, or t, is 5.625. You'll notice it's a positive number. Time cannot be negative. So this is our time, in seconds. That's all it'll ask again. Alrighty. An apple is launched directly upward. Alrighty, so if we're going up, we're coming back down. This is going to be another one that goes up and then down. And I can tell that again, it's going to be a maximum again, also because this is a negative. So again, maximum height, we're looking for vertex. So we're going to use the axis of symmetry equation again. So, and you know what? It's the same numbers, so everything's the same. So I'm going to go ahead and say x equals, I'm going to say t equals x, so I can keep that straight in my head, equals negative b over 2a, equals negative parentheses over 2 parentheses. Now I've got to go back to my equation, which they gave me in the problem, and I've got to look at my a and my b. So in this case, my a is negative 16, my b is 64 this time. So I've got 64 right here, and negative 16 right here. So negative 64 over negative 32. This is going to give me a nice even 2. A nice whole 2. Now again, I need to take that and plug it back into my original equation. So I've got height is equal to negative 16, leave some parentheses, don't forget your square, plus 64, some parentheses here, plus 80. I'm going to take my 2, put it back in here, and my final answer is going to be 144. That's how high it went. That's the highest. That was the maximum height for it. How many seconds will it take for the apple to reach the ground? Okay, so again, we've got the height is at 0. It's on the ground. So I'm going to set my equation equal to 0. You guys can do it in the front. A lot of you, I've noticed, prefer to put it at the back though. So I'm going to do that as well. Let's do negative 16t squared plus 64t plus 80. I try to make my t's the ones that are kind of the cursive looking ones so that they can stand out for my plus signs. Don't forget to set that equal to 0. Now, we're this time, instead of factoring it, we're going to go ahead and use the quadratic equation. So I'm going to identify my A, my B, and my C. So quadratic equation, don't forget, is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Some of you may remember a little bit of the song. If you remember the song, perfect. If you don't, that's okay. So I'm just going to plug this directly in. And let's see. I'm going to put it right over here. X is equal to, now I like to do this Before I do that, I like to do my discriminant so I have less things to worry about. The discriminant is this part right here. So I'm going to do b squared minus 4ac. So I've got, I'm leaving my spaces to plug in. So I've got, let's see, 64. I've got negative 16. And I've got 80. Excellent. And when I multiply that all out, I'm going to get a nice big number. It's okay. So, I believe, oh, you know what I forgot? I totally forgot to square. And that's okay. If you need to look back to your equation, you can square. So I've got this nice large number to help me make sure I type it in right. Okay, so now I can come back over here, and I've got x is equal to negative. Negative is part of our equation. It has to be there. I put my parentheses, plus or minus the square root of 9216. And while I've got this, my b is 64, so I'm going to put 64 here, all over 2 times negative 16. Run out of room, give me a second. So now I've got negative 60x equals negative 64, which 64. Remember, t is equal to x, guys. Whoops, sorry. T, of course. T is equal to x. So I've got negative 64 plus or minus the square root of 9,216, all over negative 32. Now, when you actually put this in, you're going to get the options of negative 1 and 5, depending on, because you have to do your plus case and you have to do your minus case. So here's the thing, time cannot be negative. So this is gone. Time is going to equal 5. 5 seconds. Awesome. So let's look at 3 now. All right, now guys, some of you might think these situations are totally made up. I'm going to let you know that number 3 is something that we did in my high school math class. I didn't get to participate because I didn't have that teacher. This is an actual situation and an actual thing they did in a geometry class when I was in school. So some of these are real life situations. So let's see. Again, I'm reading through it first. I see they give me the equation with all the important information, and they haven't given me anything else extra. So find the maximum height again. Maximum height of the container, again, vertex. So this time, I'm just going to go ahead and go straight to my axis of symmetry. So you'll notice something interesting. My axis of symmetry is equal to x, which is equal to t, which is equal to x, negative b over 2a. So in this case, a lot of you might immediately be putting in 25. Like, okay, let's move this is the second number. But wait! What letter is 25? If we go back and label first, I know that this is a, because it's t squared, but b is missing. So what we have to put when b is missing is 0. This is actually c. So it doesn't really matter what the bottom is anymore because 0 over anything is going to be 0. So it looks like the maximum height is going to have to be figured out by plugging 0 in. So I've got h equals, wrong color, let me do h equals negative 16 plus 25. So I've got to plug my 0 in here, and I find out that the h is 25. So the maximum height is 25 feet. I believe it's feet in this one too. Feet, yes. 25 feet. How long will it take for the container to reach the ground? Okay. So we're going to, again, set it equal to 0 because we want the height to be 0. So I've got negative 16 t squared plus 25 equals 0. All right, we're going to inverse the 25 by subtracting it. I've got negative 16 t squared equals negative 25. Divide by negative 16 to get t alone. And then I've got t squared equals 25 over 16. So I'm going to go ahead and take the square root of both sides. I'm going to leave it in fraction form. When you do this, you take the square root of the top of the fraction and the square root of the bottom of your fraction. So I've got t equals 5 over 4. Wait a second, don't forget your plus or minus. But wait! We can't do plus or minus. Time cannot be negative. So, for example, usually I would list, whoops, sorry. Normally, I would say t is equal to negative 5 over 4 and 5 over 4. And then we would have our nice squiggle lines. But however, this case, we cannot have the negative. Time is not going to be negative. So the only answer is t is equal to 5 over 4 seconds. We're going to go to 4 now, so turn your paper over. Alrighty. So here we go. We're going to just, this one's only got one part, so we're good to go. I'm going to check, and it looks like they give me my equation again. And they want to know, they already know how long would it take the penny to strike a 6-foot tall person. Now, they've been telling us this stuff in feet every time. So the height is not the ground this time. The height is the height of the person. 6-foot tall person. So negative 16 t squared plus 1,250 will be equal to 6 this time, not 0. We're hitting an object above the ground, in this case a person. So when we subtract 1,000, when we inverse our 1,250, we're going to have to inverse it from 6. So I've got negative 16t equals negative 1,244. So you need to divide by negative 16. And we've got t squared equals 77.75. So we have a similar situation to before. I take the square root. I take the square root. I've got t is equal to negative 8.82 and positive 8.82. But time is in time. T is for time. It's in seconds. You cannot have negative seconds. So t is only equal to 8.82. Jump on down to 7. That'll be our last problem. Alrighty, so we're looking at Eva. She's jumping on a trampoline. The question is, when she jumped on the trampoline, would she reach a height of 14 feet? So we've got to determine if that's going to be possible. So let's first determine what her maximum will be anyway. That's going to take us to our axis of symmetry, which is going to be equal to x, which is equal to t, equal to negative b over 2a. So I've got negative parentheses, 2 parentheses. Let's make sure we label our a, b, and c. Make sure we don't get tricked like we almost did last time. Here's my equation. I've got a because it's the t squared, b because it's t, and c. It's all by itself, constant. So I've got 20 and negative 16. So we're going to end up with 32, and that's going to be equal to 0.625. I'm going to take that, I'm going to plug it into my equation. So, I want to know what the highest she can go is. So, I'm just going to leave it at h and see what happens. So, height equals negative 16, parentheses. Leave that for what I'm plugging in. Alrighty. Let's hope I left enough room. 0.625, 0.625. Excellent. Now when you do this, you're going to come up with an answer that the height is equal to 12.25. So the question is, does she reach 14 feet? Well, no. Her maximum height that she's going to get to is going to be 12.25 feet. She can't get to 14. So, no. Sweet. All right, guys. That was the end of the video. If you have questions, ask your teachers. Have a great day.